Alright guys, so we're going to go ahead and start your next unit. On this unit, you will be able to determine the relation of the function, and you will be able to find the value of the function. Okay, so let's go ahead and start. What's a relation? Well, think about being in a relationship. If you are in a relationship, it needs to be you and your boo, and it needs to be you and your boo. So if you think about that, a relation is a set of ordered pairs. For example, that right there, -2 and 5 is an ordered pair. That means that -2 can only be paired up with 5. -1 is paired up with 0, and so on. Okay? So just like in a relationship, it should only be one girlfriend, one boyfriend, one boyfriend, one girlfriend. Alright. You can also see it this way as a map. This is called a mapping. Okay? Now, a mapping, your x's are always going to be first, and your y is going to be second. Now, you can make order pairs out of that. That means that the 0 is paired up with the 0. The 4 is paired up with the 2, the ordered pair. The 5 is paired up with the 5. And the 8 is paired up with the 9. So those are your ordered pairs. Alright, so what's a function? A function is a relation, but not all relations are functions. A function is a relation in which each element of the domain is paired with exactly one element of the range. Now you might ask, what is domain and what is range? Well, domain would be your input, which are your x's, and range is your output, which are your y's. Now, when you write an ordered pair, you write the x before the w. You always move on your x-axis, and you go up or down on your y-axis. Well, this is the way that I like to remember it. Domain comes before range. Now, I know this because in the alphabet, x comes before y, and guess what? D comes before R. Another way of saying it is that there is one and only one output with each input x. So for example, when you have a function, you plug in your x, you put your input, and here comes your output. And that would be your y. So this is your domain, and that would be your range. Remember, x comes before y, d comes before r. Alright, so let's label. On a function notation, y equals f of x. That's how you write it. That's how you read it, I'm sorry. Your y is your input. Your f of x is the name of the function. I'm sorry, f is the name of the function, and then your x will be your input. It's just another way of writing an equation, a linear equation. So I can write y equals 2x plus 3, but I can also write f of x equals 2x plus 3. It's the same thing. Alright, so determine whether each relation is a function. Remember, relations are just ordered pairs with a pair of x's and y's. A function, every x has to have a y. And a unique x has to have a y. What does that mean? The first thing that I like to do is I like to write it on an x and a y table because this is hard to do. So I'm going to go ahead. I'm going to highlight all my x's. I'm going to write them down. I usually like to write them in order, but I really don't have to. So I'll do 2, 3, 5, and 4. Now let's go ahead and do the y's. The 2 is paired up with the 3. The 3 is paired up with the 0. 5 with the 2, and 4 with the 3. Now I'm going to have to take a look at my x's. If x's do not repeat, this is a function. If they do repeat, it is not. So do you have any values of x in which, take a look at your table, values of x. Do the x's repeat? No, they do not. So yes, this is a function. Every domain is different. So for a function, or should I say in a function, elements of the domain which would be your x's, do not repeat. That's what you need to understand. That's why it says over there that every domain is different. They cannot repeat. Alright, so let's go to the next one. Determine whether the relation is a function. There's our relation. Let's go ahead and write down my x and my y. These are my x's. You don't have to repeat them. I'm sorry, you write them all. That'll be 4, 5, 5, 6, and 1. And this is 1. And then my y's would be 1, 2, 3, 6, and 9. Okay, so let's go to my x's. And I automatically see when I copy that at x's, the elements of the domain do repeat because there's 2 5s. So this will not be a function because 5 is paired with 2 numbers. One of them is the 2, and the other one is the 4. So if x's repeat, nope, it's not a function. If x's do not repeat, yes, it is a function. So let's go ahead and do this. Let's go my x's. 1, 2, and 3. My y's, 3. 3, and 3. Now you can tell me if this is a function or not. The correct answer would be yes, it is a function. A lot of people want to say that it is not a function because they take a look at the y. But remember, we're only looking at the elements of the domain. So you look at the domain, and the domain says, remember, this is the only one that you need to take a look at. There's nothing that repeats over there. The y's can repeat. It's the x's that cannot. So yes, this is a function. Okay, now what happens when you have a graph? Then you got to do the vertical line test, okay? If any vertical line passes through more than one point of the graph, then that relation is not a function. And yes, because it's passing through more than one point, which means x is repeat. I'm going to show you what I mean by that. Are these functions? Okay, so I like to take my highlighter and start making lines, vertical lines, all the way down. That's where it touches, that's where it touches, that's where it touches. It only touches the vertical line, my highlighter line, once. So guess what? Yes, it is a function. Let's go to the next one. Take your highlighter and start making lines. You go for the coloring pencil too. Make sure they're straight, no wiggly like mine. and touches there, 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 and there. You can also do this with your pencil. That's why it's called a pencil line. So it only touches that highlighter line once, which means, yes, it is a function. Now look at this one. Take your highlighter and start making lines. And I'm only going to make one because the minute that I do that, I notice that it touches there and it also touches there. So because it touches more than one, this is not a function. Alright, so let's practice. Highlighter. Is this a function? Yes, it is. Only touches once. That highlighted line only touches once. What about this one? If I make a line, what happens over here? It touches everywhere in that line, doesn't it? Everywhere. It gives you a view, but it touches everywhere. So this is most definitely not a function. So look at the difference of those two. This is a horizontal line, and a horizontal line is always a function, but yet a vertical line is not a function. And that makes sense because it's called the vertical test. And if the line is vertical, how is it going to pass the vertical line test? It can't. It's a line on top of a line. Alright, let's do this one. That's a no-no. It's a done. Touches twice. What about this? Now, in this one, you can consider quickly. I'm going to go ahead and do a couple. There, and there. So, I think it's a function. Alright. Is this the graph of a function? And if you're going to correct us, and the answer will be only touches one. Given f of x equals 3x minus 2, we have to find f of 3. Okay, now remember, when this is the same thing as y equals 3x minus 2. This was the same thing as f of x, which means that x needs to be replaced by what? The 3. You see how it's in the same spot? So all you have to do, all you have to do is go ahead and plug it in. Okay, so that would be 3 times 3 minus 2. 3 times 3 would be 9 minus 2 would be 7. So f of 3 equals 7. To evaluate. Same thing as evaluate. Alright, let's do the next one. What about when you evaluate the function when it's f of negative 2? Alright, sorry about that. what if it's f of negative 2, which means that x equals negative 2. So then this would be 3 times negative 2 minus 2. 3 times negative 2 would be negative 6 minus 2 would be negative 8. So f of negative 2 equals negative 8. Alright, let's do this one. Given h of z equals z squared minus 4z plus 9, find h of negative 3. So this will take the place of the z. So let's see. The function is c squared minus 4z plus 9, where z equals negative 3. So this is negative 3 squared minus 4 times negative 3 plus 9. Negative 3 squared would be negative 3 times negative 3. That is positive 9. Negative 4 times negative 3 would be negative 12 plus 9. So 9 plus 9 is 18. 18 minus 12 would be 6. So h of negative 3 in this case would be equal to 6. Alright, so given g of x equals x squared minus 2. Now remember, another way of writing this would be y equals x squared minus 2, where that would be the value of your x. So x equals 4. Now all you got to do is come over here and substitute by the value of x. So that would be 4 squared minus 2. 4 squared would be 4 times 4. That's 16. Take away 2. The correct answer would be 13. Alright. The next one says, given f of x equals 2x plus 1, find negative 4 f of 3 times f of 3 minus f of 1. Okay. Now you can chunk this and do the parentheses first. The parentheses has f of 3 minus f of 1. So I'm going to go ahead and do f of 3, where I'm going to substitute the value of x by 3. So this would be 2 times 3 plus 1. 2 times 3 would be 6. 6 plus 1 equals 7. So f, this part over here would be 7. Now let's do f of 1. F of 1 would be, now I'm substituting over here 1. 2 times 1 plus 1. 2 times 1 is 2 plus 1 equals 3. So now this over here becomes 3. So I'm going to rewrite that. That would be negative 4 times, and that's your bracket instead of a parentheses, is the same thing. 7 minus 3, because f of 3 would be 7. F of 3 was 7, and f of 1 was 3. And now we use resistance right here. 7 minus 3 would be 4. And then 4 times, negative 4 times 4 would be negative 16. Alright. Alright, so now that we are done with the lesson, what you need to do is go ahead on page I believe it's 14. You can either fold your paper in the notebook, or you can just, with the nice and neat line, make a little ruler, divide that page into one column that says function, and then another column that says non-function. So do one with function, and then do another one that says non-function. Okay? After you've done that, we're going to go ahead, and this is the worksheet that I gave you. This is the pink sheet of paper. We're going to decide whether these are functions and non-functions. Okay? So I have a line. This is the first one on your paper. The line goes, I believe, through here. So let me make that a little so let's go ahead and do that. So that's the line. After you've done the line, see in here, that's the line. You can connect the lines, or you can just go ahead and make the vertical line test, okay? Now this is a graph, so we need to go ahead and do the vertical line test. I'm going to go through, and I'm going and make a vertical line through all those points. Do x's repeat? No, they do not. So would this be a function or a non-function? This would be a function. I can do all that stays behind. That's lovely. Okay, so you're going to move this one on that side of the paper that says function. Alright, let's go to the next one. Is this a function? Most definitely not. Because it does not pass the vertical line test. Again, look at this one. I'm going right to the right on the paper. So just here and here, here and here. X's here repeated, so it's on more than one. So this is not a function. Now, what about this one? For this one, I would recommend either doing an X and a Y table, or writing the coordinate, the pair, the ordered pair, right on top of the line like I did on the video. Now that gets a little messy, that's why I don't like to do that. So what I like to do is just go ahead and write on X and Y table. 0 with 2 and 0 with 3. And I can stop because X's cannot repeat. And obviously I have to pair up with 0. Two range elements pair up with the same domain element. And remember, X's cannot repeat. So this would be another. Now, look at this one. Make vertical lines. Every time you have a graph, I just like to do the vertical line test. Do those lines hit that line more than once? Nothing else. So this would be a yes. It is a function. Now what about this one? Do the X and the Y table. So 1 with 6, 3 with 6, 5 with 6. Now remember, you don't look at the elements on your domain, on your range, you look at the elements on your domain. And there is no repeats over there. So yes, this is a function. Alright, I'm going to go ahead and I'm going to start moving them. That was a no, so it goes over here. That was a yes, so it goes over here. this was a no, this was a no, and this was a yes, so that I can have that mess out of the way. So what you guys are going to have to do with your sheet of paper is you're going to have to cut them off. It doesn't matter the order, as long as they're ordered the right column. So all these to the right will be non-functions, and these to the left, they will be functions. Okay, so let's take a look at this table right here, x and y. So we have x and y, so take a look at the elements in your domain. Do you have any repeats? No, you don't. So yes, this is a function. Vertical line test for this one only touches one. So yes, so vertical line for this one as well only touches one. So that's a yes. So those three are yeses. Let's go ahead and do an x and y table for the next one. So x and y. Let's do the x's quickly. 5, 2, 3, and 8. I'm sorry, later. 1, 2, 3, and 8. And actually, I'm going to go ahead and stop because all I need to take a look at are my elements or the domain, which are my x's. There is absolutely nothing that repeats over there, which means it is a function. Okay. Now let's do the vertical line test on this one. That point is okay. That point is okay. Look at this too. That vertical line is hit twice. Here and there. So this would be a no. Vertical line test for that one. Hits it twice. So that would be no. Okay? So let's go ahead and put them in the right location. These two were no. And the remaining ones are yes. And oops, I'm going to put them over here. So at this point, what you need to be doing is gluing all this with functions on one side and non-functions on the other. All right, and that would be